This is part 2 of the lecture regarding architecture, and in this part 2 we will look more at the results and consequences. First, when we build an architecture, so when we have followed the steps of Deming and we have set up this whole system for our processes, the links between the processes, the people and the tools, technology we are using in those processes to fulfill the target, the goal of the organization. What we will have as a result is first the structure. In that structure and in the drawing, in what you have to communicate about the structure, is what we call the hierarchy and the hierarchy. Hierarchy is how is the structure of the organization built in levels of authority. But be aware that you might have levels of authority, but at a certain level there might be several teams operating. For example, management teams. The people in those management teams operate in a network type of fashion. So in fact, an organization is not a pure hierarchy, but it's a hierarchy because it's a mixture between authorization structure and teamwork. The second thing you will produce as a structure are the systems, the people, their responsibility, and the tools, the automation being used, the robots, artificial intelligence, algorithms, all of that. And let's concentrate a little bit, for example, in the architecture of artificial intelligence. When you have a single agent, it's quite simple because you can use a kind of system theory. You have sensor input, you do a kind of process, you have control, and you get an action, you get some output. When you have more than one agent with an artificial intelligence system, it's already getting more complicated. Because it might be that this one contains already 3 different agents, and so all these agents are influencing each other based on what happens in the environment. These 3 agents as well, they will influence each other. So you will have an organizational relationships. You will have interactions, but also influences. And that's the same with people. This is very much like a hierarchy I was talking about, that there could be an authorization level of this system which is higher than these 2, but inside the system we have a kind of cooperation between the different agents, which is in fact an architecture of a multi-agent for artificial intelligence, but which can also be used for an architecture of multi-people inside teams. We were talking about coherence, responsibilities, strengths and weaknesses of the organization, risks. What is happening? How are we doing the control? How do we measure, and what kind of control is built into the system? By that I mean, it could be that the system gets data which are out of border. How is the system acting on that? But it could also be that the system is detecting some funny pattern which is not normal and has to report on that, because that could be an indication that somebody is putting in data or processes to do with cybercrime. So how do we manage control? This whole coherence, what is being controlled where, and what kind of signals do I get out of the system, should be designed at the very beginning. So in fact, for auditors, we should not just have a system which is looking at email structure, and another system which is looking at the cloud, and another system which is looking at a different database environment. It should be a coherent system as well. It should be a coherent control system, because the indications that something goes wrong might appear at different places at the same time. How are we going to detect that, and how are we going to use that? And the third result you're getting are the reasons for the decisions. Your structure and your target are intertwined. It's a design process. Architecture has to do with design, and you have to design for beauty, firmness, and maintainability. So your decision whether you have an open system, cloud system, or a completely closed system, whether it's central or decentral, whether you use proprietary software or external libraries, whether you use your own tools or some standard tools, those are all decisions which are directly depending on your major decisions regarding the target, the goal of your organization, the purpose of your organization, and the architecture which is the result of that. But let's have a look what's happening when you start using open source. Open source means that you use all the open source database tools, which means immediately that all the libraries are a risk. And you will have to check always whether you are still using correct software. Open source doesn't mean, oh, everybody is always checking it and we will find out in time when something goes wrong. No. That will certainly go wrong in the end. Decentralized apps in smartphones. What does it mean? Well, it means that already with just a very small penetration in the market, let's say of 20,000 people, 20,000 people using a piece of software at the same time is completely different than a centralized system where maybe maximum 1,000 people are using the same function at the same time. You immediately have privacy problems when you have decentralized apps. You immediately have all this extra communication, which will induce problems like cybersecurity. So, yes, open source, even when it's accepted by the architecture, when in fact it is a consequence of the architecture, you still have to see the risks related with it. But you also have risks for the closed development environment, because it means that you need a large development team. You have to make everything yourself. You are building unique software, which might stop you for the future. If you made your own software and somebody changes, for example, a law, you have to adapt it. And when you have no more knowledge about all the algorithms in that system, then you have a major problem. The other thing is, look at your database systems. Are we going to make our own database environment, or are we using external? Because as soon as you start using external, you're not closed anymore. When you use a closed development environment, the use of these central apps is very difficult because you have a lot of specific, unique software running centrally. And all the communication between that system and the decentral apps have to be written unique as well. So you will have a lot of maintainability problems. And this lock-in for your closed development environment could result in an enforced changeover to a completely new environment in time, at huge costs and with a lot of time delay. When you use a central architecture, it always means that you need a very high capacity for processing and transaction handling. And the use of these central apps will be difficult because of your central system environment. You are focused on a central environment, a central architecture. So the amount of processes which are done centrally will be very, very small. Maybe it's only access. So you cannot use all the general tools. So you have to define maybe a separate environment for other processes like office space, which is completely separated from your central architecture environment. Be aware of that. But the consequences for a decentralized architecture means that you have to be open. So you will have many points of interaction. As I told you already, high risk. You will have to use of decentral and central databases, which will have a lot of activities and other stuff coming from users in communication with the central applications. You get high volumes, which makes you vulnerable for DDoS. So you have to make very robust software which can detect attacks or sudden peaks in your usage. Your app environment, if you don't do that, could die very quickly in a few days when everybody is using at the same time. We see it all the time when people introduce apps too fast and they don't calculate what happens when there is a lot of usage. We see those apps completely go down the drain immediately. The apps must be very, very clear because otherwise you will have a lot of problems with your user support. And your central software must be very robust because if mistakes are made in the central software and people don't notice it, but maybe later on, you will have a major problem. So the conclusions are, when you make a system architecture, be aware that you don't start with a system architecture, but that you start with your organization structure, that you start defining why are we here and what's the purpose, what's the goal. And then you can start deciding how you want to have your structure. And of course, that structure is depending on the target group, the people for which you are there, the target of the organization, the purpose of the organization for a certain group. And when you decide for a central solution, you will be less flexible, you will have high maintenance cost. When you decide for a decentral architecture, you will be highly flexible, but you will have high test cost and a high security risk. And then I will finish this lecture by some remarks about tools. Because tools are always used personally. Everybody, every single person in your organization, independent where he is or she is, she will use or he will use his own set of tools. And he will use data which he thinks are necessary for his own performance. And the trouble is, each user is normally in an open environment. During the pandemic, we have seen that people started working at home. Now, most organizations did a lot to protect their systems. But working at home also means that everybody who is with you in the same house suddenly can see or maybe can have access to the same data you have. So it's an open environment, which means that the data which are entered are often from an unknown source. So when somebody is using tools during his work and those tools are not managed, they are a source of a high risk for misuse. This is independent whether the tool is central or decentral available. Also, when I give the tools available from a central point from the organization, with a central maintenance, it still could be that the data which are being used are being inputted and are in fact data coming from outside. So there's still a risk for leaking, I call it, for data getting into the system which are not controlled in this way. The same is for the network. High risk means that you need a high centrality and you have to be less open. It even means that when you are very high risk, think about defense organizations, you have to decouple from external connections at all. Also, that means that people are not allowed to enter data using tools. All the data should be centrally available, and if a user wants to use some particular data, it should be first checked and then also given available centrally. When you use external server environments, insight in those risks are necessary. And you have to decouple always for high risk elements. In fact, I would go that far from the point of view of cybersecurity that you have to measure and control all the network transactions using pattern recognition and artificial intelligence to find out if there's any anomaly. These are the two lectures on architecture. If you have still some questions, don't hesitate and contact me on the mentioned email address. And I thank you for your attention.